We are living in an era where almost everything is being discovered and explained. But even after so much development in science and technology, there are still things that we do not know about our world. And sometimes the unknown things are not only strange, but also scary. There are many such things that we do not know about our world. One of them is what is dark matter and dark energy. These are the two greatest mysteries of our modern time. You must be thinking about what these mysterious things could be. Well, according to scientists, 80% of the entire universe is made up of these two things, dark matter and dark energy. However, it has been observed that both of these things have a profound effect on the entire universe, but we cannot see them, nor can we touch them. We cannot detect them with any of our instruments. And the reason why we do not know about them is that they are invisible. You heard us right. Dark matter and dark energy are invisible. They do not interact with ordinary matter or light, so they cannot be detected by any of our instruments. However, we know their existence because of the impact they have on other things. So this raises the question, how do we know about their existence if we cannot see them? Well, it's pretty simple. This is because of the effect they have on galaxies and galaxy clusters. Dark matter is something that we cannot see, but we know it exists because of the way it pulls at other things. It affects objects in a way that we can observe and measure, which gives us clues about its presence. Similarly, we cannot see dark energy, but it causes the expansion of the universe to speed up, which tells us that it's there. We're going to tell you about all these things in detail, but before we do that, don't forget to subscribe so that you're the first one to watch our upcoming videos. Also, hit the bell icon so that you never miss out on any of our videos. Let's start with the dark matter. What exactly is dark matter? Well, let me tell you that dark matter is a hypothetical form of matter that is invisible to electromagnetic radiation, hence the name dark. It does not interact with baryonic matter or light, making it impossible to detect with current instruments. However, its presence is inferred from its gravitational effects on visible matter, as well as its contribution to the overall mass of galactic and supergalactic structures. In addition, dark matter is thought to play a role in the formation of large-scale structures in the universe, such as galaxy clusters and superclusters. Despite its elusiveness, scientists believe that dark matter is an essential component of the universe, and that understanding its properties and behavior is crucial to unraveling the mysteries of the cosmos. Now let's come back to the question, how do we know about its existence? As we mentioned earlier, we cannot see dark matter, but we can observe its effects on other things. For example, stars in the outer regions of galaxies rotate faster than expected, which suggests that there is some invisible mass in the galaxies that is affecting their rotation. This is known as the rotation curve problem. Another observation that provides evidence for the existence of dark matter is the gravitational lensing of light around galaxy clusters. When light passes by a massive object, it is bent by the object's gravity, causing the object to appear distorted or magnified. This effect, known as gravitational lensing, has been observed around galaxy clusters, and it is stronger than expected based on the amount of visible matter in the clusters. This suggests that there is a large amount of invisible mass in the clusters that is contributing to the gravitational lensing. Scientists believe that this additional mass is dark matter. Another interesting fact about dark matter is that it interacts with itself only through the strong nuclear force and gravity. This means that it does not interact with the electromagnetic force, which is responsible for most of the forces that we experience in our daily lives. As a result, dark matter is invisible to us, and it is also difficult to detect because it does not leave any electromagnetic trace behind. It is important to note that dark matter is different from antimatter, which is a type of matter that has the opposite electric charge of ordinary matter. As for how much dark matter makes up our universe, well, it's thought to account for approximately 27% of the total mass and energy content of the universe. However, it is worth mentioning that dark matter is not evenly distributed throughout the universe. It is believed to be concentrated in the center of galaxies and in the halos around them. Let's move on to the next thing, which is dark energy. The dark energy is a mysterious force that scientists believe makes up 68% of the universe. It is an unknown type of energy that permeates all of space and is responsible for the accelerated expansion of the universe. But what is strange is that we do not know much about it, because it is invisible and does not interact with matter or light. The only evidence we have for its existence is the observation that distant supernovae are more redshifted than expected. This means that the universe is expanding faster than it should be if dark energy did not exist. Scientists first noticed this unexpected acceleration in the late 1990s, and they were puzzled because they could not explain it. They hypothesized the existence of dark energy as a possible explanation and named it quintessence, which comes from the Latin word quintus, meaning fifth. This is because they thought it might be the fifth fundamental force of nature after gravity, electromagnetism, and the strong and weak nuclear forces. However, despite numerous attempts, scientists have not been able to detect dark energy directly, and its true nature remains a mystery. One of the challenges in detecting dark energy is that it is a very weak force, and it becomes weaker over time. This means that the further away an object is from us, the less affected it is by dark energy. As a result, scientists have to study very distant objects, such as supernovae, to detect the effects of dark energy. Another challenge is that dark energy is homogeneous, which means that it has the same density throughout space. This makes it very difficult to distinguish its effects from those of other forces. Despite these challenges, scientists have come up with some creative ways to detect dark energy. One of them is to study the cosmic microwave background radiation, which is the oldest light in the universe. By studying the patterns in this radiation, scientists can look for any anomalies that may be caused by dark energy. Another method is to study the large-scale structure of the universe by looking at how galaxies and clusters of galaxies are distributed throughout space. Any deviation from the expected distribution may provide evidence for the presence of dark energy. In addition to these methods, scientists are also exploring other ways to detect dark energy, such as by studying the behavior of neutrinos, which are tiny subatomic particles that can travel through matter and have very weak interactions with other particles. Some theories suggest that neutrinos may have a small but measurable interaction with dark energy, which could provide valuable information about its properties. As for how much of the universe is made up of dark energy, well, it is estimated to account for approximately 68% of the total energy content of the universe. However, it's worth noting that dark energy is not a type of energy in the traditional sense. It does not have any mass or rest energy, and it is not associated with any particular object or event. Instead, it is a property of space itself, similar to how the curvature of space can affect the motion of objects. While we may never be able to directly observe dark matter or dark energy, the search for these mysterious phenomena has led to some incredible discoveries and has deepened our understanding of the fundamental laws of the universe. As scientists continue to explore the nature of dark matter and dark energy, they are sure to uncover new and exciting insights into the workings of the cosmos. And that's all for today. What did you think of this video? Let us know in the comments below. Like always, if you want to see more amazing space videos, stay tuned. Have a great day, and thanks for watching.